All right, so here we are with a little bit of review from Algebra 1 and in fact Algebra 2. So we're going to be solving systems of two equations. We're going to be doing it by graphing. We'll also be doing it by elimination and substitution. And then we'll kind of do a trickier one where it's not just two linear equations, but it's just two equations in general. So there could be exponential or quadratic or a lot of mix of different number of types of solutions of where they might meet. So this is chapter 7, section 1 of PreCalculus. So the first thing that we're going through here is solving the system by graphing. So you will need some graph paper for that. The first step is to solve the equations for y, because it turns out you cannot put them on the graph paper very easily without having them as y equals. Then you're going to graph them on the same grid and identify the solution, because the solution is a coordinate point, and that point is going to be where they meet. So, coordinate point. All right. So that means that we need to take the time to rewrite each of these. So 2x minus 8y is going to equal 24, but we're going to take the time to move the x over. And then divide by that number in front of the y. And so our y equals equation, which is a little easier to graph, is a positive from the two negatives, fourth. 2 over 8 is 1/4 with an x, but then minus 24 divided by negative 8, which is 3. So we take the time to graph this blue equation here by starting at negative 3, and then from there going up 1/4 squares, up 1/4. But then also down, because you never know if the equation is going to meet over here. And so that is our first equation, and we're going to hopefully find where that one meets this next equation here. All right. So in the next equation, we are going to solve this one by moving our x over as well. And so now we have 5y equal to negative 3x plus 2. But if we divide everything by 5, we're going to get y equals negative 3/5. And I do keep it like that because graphing with fractions is easier than decimals. And then plus 2/5, which is actually not any more helpful. All right. So to graph this one here, let's see how I want to do this. We're going to start at 2/5, which is the y-intercept. So 2/5 is going to be about 0.4, so a little less than half. And then from there, we're going to go down 3/5. So down 3 from there goes here, 2, 3, and then over 5, 1, 2, 3, 4, 5. And as you can see, that is not going to be where they meet, but it is going to be along this axis here. And it turns out that if we draw it appropriately enough, we hopefully can see that it will actually be meeting at this coordinate right here. And the coordinate of that is 4, -2. You can always check by plugging in. So for instance, if I plug in an x of 4, that's 12, and then minus 10, plugging in a -2, does in fact equal 2. So that would have been one of the coordinates as well. All right, so that's solving your system by graphing. Usually when there's a solving by graphing equation, they will in fact meet at an actual coordinate versus something like 2/5, 4/5 or something. So that's why I knew that point would be there. All right, so that's the solving a system by graphing. Then we have solving a system by substitution, which is really one that we tend to avoid. We avoid elimination, but substitution is technically taking one and solving for either x or y, and then plugging that one into the other equation for that x or that y. And then you solve it and plug your answer in. So we will take the time to do each of those steps. So step 1 is to solve one equation for either x or y. And since I'm pretty good at solving for y already, we'll go ahead and solve this top one for y. So if I'll rewrite it so I don't skip any steps. subtract a 2x, we get negative 8y equal to negative 2x plus 24, and then divide everything by negative 8. And so our solution is y equals positive 1/4 x minus 3, which I now realize is the same exact set of equations as this one. Okay, so we do already know that our answer is going to be 4, negative 2. We're just using substitution to clarify. So I have already written this as y equals. So now what we're going to do is take this second equation and we're going to substitute in that y value as this equation. So it used to be 5y, right? But now we're going to actually rewrite that entire equation into this place for y. So 3x plus 5, and then instead of an x, or sorry, in this case a y, we're going to actually put in that entire equation. So we're going to put in a 4th x minus 3. So notice that between this line to this line, we now had 2 variables to only 1 variable. And because we know how to solve things with only 1 variable, we'll be able to continue with this to find our x. So in order to solve this, we're going to distribute our 5. And so we'll have 3x plus 5/4 x. 5 times 1/4 is 5/4. And then minus 15. Combining the like terms here, we have 3 x's and 5/4 of an x. And so technically, if we don't want to have any more decimals, that's 1 1/4 or 1.25. So that's 4.25 that we'll subtract 15 from, and x minus 15 equals 2. Add a 15 to both sides, and we'll get 4.25x equals 17. And then dividing by 4.25 does in fact get us back to our x value of 4. And so remember that we were trying to solve to get this solution, which was just a coordinate, and right now we have 4. But now we need our y value, and so in order to get our y value, we have to plug the answer back into step 1, so into one of these equations, and solve in order to get our y. So if I choose this equation, for example, I have an x that is 4. And so if we distribute that 4 and that 1/4, we get 1 minus 3, or a negative 2. So that means that our x value is 4, our y value is negative 2. And so this is our coordinate of intersection, which, again, we also got by graphing. So just talking over this one just a little bit more, remember that substitution is plugging one equation into the other. Now, officially, if you remember back to Algebra 1, we rewrote each of these as y equals, and then via the transitive property, we took out the y's and just set them equal to each other. So we would have algebraically solved 1/4 x minus 3 equals negative 3/5 x plus 25. So you could also solve both of them for y and set them equal to each other. All right. So the next one is elimination, and again, this is the one that I said that a lot of times we avoid. Remember that we are using the same equations as before, so we will have the coordinate 4, negative 2 as our answer, as a goal. But the first thing that we're going to do is get the coefficients x's and y to be opposites through multiplication. So the idea of elimination is that you are going to be able to add these two equations together, and one of the variables will eliminate because it's an opposite. So in order to get an opposite, we need to get the coefficients of the x or the y to be opposites, and then we'll add them together. So seeing as how these values here are up front, it's a little easier to look at. I'm going to multiply this entire equation, which will still then be true, by -3. If I multiply this entire equation by -3, I will have a -6 out front here. If I multiply this second equation by a +2, not a negative, I'll get +6, which -6 and +6 will cancel, and I won't have any x's anymore, and therefore I'll be able to get my y. So I'm going to add these two equations, but before I do that, I'm going to distribute the -3. And so I'll have -6x plus 24y equal to -24 times 3, which is 72. All right, and I'm going to add that to the second equation, which again, I'm distributing a 2 into each of these pieces. So we'll get 6x plus 10y equals 4. Again, I'm going to add each column. So in this case, I will get 0 x's, which is what I was hoping for, eliminating the x's. Adding these two together, you're going to get 34 y's. And then adding these two together, you get -68. If we then take the time to divide by 34, we now get a y of -2. Huzzah, because we had that as our answer before. So we know that y is -2, and now we're going to plug it back into either of the original equations and get our x value. So step 4 says take this -2 and plug it into one of the original equations. So 2x minus 8y equals 24. But of course that y is actually -2. So solving that, we have 2x plus 16 for this value. Subtracting 16 gets you a 2x equal to 8. Dividing by 2, and we get an x of 4. So our x value is 4, our y value is -2, and so yet again we get back to that original coordinate. So 3 ways of going through and solving these equations. Again, one of them was graphing, and we found that point, which was 4, -2. The next was substitution, where we plugged one equation, this blue part here, into the other equation and solved. And then the last one was elimination, which I usually think is kind of the more algebraic one. So usually the graphing one tends to be a little bit sloppy, depending on how nice you are at graphing. So I choose to ignore that one a lot. But all right. So the next thing that might happen as you are solving these super awesome equations is that instead of getting an x equals 4, you might get 0 equals 2. And you're saying, where did my variable go? And it turns out that is because before you recognized anything, you were actually given a set of parallel lines, which meant that there is no intersection, right? Because there's no solution for lines that don't meet. So if you're ever kind of just robotically going through all of this math and realize that your x's cancel and you're left with 0 equals 4 or some other untrue or false statement, that meant that you actually started with parallel lines. And so there is literally no solution, and that is your answer. Okay. If you go through and everything cancels, but you are left with an actual even statement, like 0 equals 0 or 7 equals 7, that actually means that you all of a sudden were graphing the same line. Okay, and so there are infinite solutions. So you could literally mention any coordinate as long as it's on that line, and it would have been exactly on each of them. So we kind of think of it as on top of each other, because you would have graphed one line and then literally graphed the exact same line directly on top of it. And so you're trying to ask yourself, how many times does this line meet this line? And that would make infinite. Alrighty. So that can happen. The next piece here is I identifying the fact that there could be non-linear lines, okay? So if we have non-linear lines, you can't necessarily have a parallel circle with an absolute value graph, okay? But because of that, you end up having more than one solution. So in this case, we have two solutions values. Over here, we also have two solution values. And then over here, we have two solution values of this quadratic meeting with this square root graph. All right, so there can be multiple different meeting points. And so that's why our last example here is going to be a circle equation that meets a line. So kind of reminiscent of this one here. So there will be two solutions. So the way that we're going to do this is most likely substitution, just because you don't have necessarily the alike values here to get an elimination going on. Okay. Also, graphing is probably, again, the more sloppy option, and so it might not look very good. So in that case, or be able to be recognized easily. So in that case, we're going to take this y equation and put it in for this y, because then we will have everything in terms of x, and we'll be able to solve for x. So if I rewrite the first equation, but leave a space to put y, which I will be squaring, I'm going to plug in 2x plus 1. All right, then in order to solve this, I'm going to be squaring 2x minus 1. And please do not tell me that that's 4x plus 1. Instead, if we go back to the area model or the box, 2x plus 1 times 2x plus 1, which is squared, is 4x squared, yes, and 1, but also a 2x and another 2x. So this expanding is going to leave you with 4x squared plus 4x plus 1. So coming back over here, we have x squared plus 4x squared plus 4x plus 1. And all of that is going to equal 9. So again, this thing squared became this. All right, then if we combine all of our like terms, there is 1x squared here with 4 of them. So we're going to have 5x squareds. And then hopefully by now, anytime that you see that you have a squared, you basically always have to take this side and make it 0. So I'm going to, instead of moving the number with the number to the opposite side, I'm going to put everything over to the same side, which will allow me to either factor or use the quadratic equation. So now in this step, we can go ahead and factor this trinomial, or you can use the quadratic equation. And I know that not all of us love to factor, so we're probably going to skip that part, especially since there's a coefficient out here, which means that I'd have to find factors of negative 40 that add to be 4, and then actually go back to the box and find GCFs. So that's kind of a lot of work. So instead, we're going to do the slightly less a lot of work, which is the quadratic equation, giving an a value of 5, a b value of 4, and a c value of negative 8. So remember that the quadratic equation says that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug in each of those numbers. And so negative b is actually going to be negative 4. And I'm going to get really fancy with my colors here because all I'm doing is plugging in each of these values. So b again is 4 that I'll be squaring via the formula. And then we'll subtract 4 times a, which is 5, times c, which is negative 8. And then all of that is going to be over 2 times our a value, which is 5. And so remember that the reason that there's a plus and a minus here is because we are making a circle meet a line, and it's going to meet twice. So moving through this formula, our negative 4 stays, but then underneath here, this discriminant is going to be the square root of 16 minus 4 times 5 times 8, which we're actually adding. So 16 plus 160 is 4 times 5 times 8. And that's all over the number 10. And so we have negative 4 plus or minus the square root of 16 plus 160. And that is an icky decimal. So it's a good thing we didn't try to graph them because I'm not sure that I know where 0.2665 is on a graph. All right, so that means that our two x values are going to be negative 4 plus 13 divided by 10, and then negative 4 minus this 13 over 10. So our x's equal negative 4 plus divided by 10. So 0.9266, but then also negative 4 minus 13.266499916. And so we also get negative 1.7266. So those are both the x values, but remember that we're trying to solve the system, so we need two equations, which means that we need to plug in this x value here to get a y, and this x value as well to get our y value. And of course, I'm going to plug it into the second one because that one is a whole lot easier to plug into than the other one. So our y value for this one, if we plug in 0.9266 and multiply by 2 and then add a 1, we're going to get, didn't press enter yet, 2.8532. And then the other y value, if we plug in this negative 1.7266, we're going to multiply that by 2 and add 1. So again, this weird value times 2, but then plus 1 leaves you with negative 2.4532. So ultimately, our two coordinates of the intersection are, with a little less decimals, 0.93, 2.85 is one, and negative 1.73, and negative 2.45. So those are the coordinates where it meets. This one does use a lot of steps that hopefully we are a little bit familiar with, or at least can remember. So squaring something, again, you're going to have to expand with FOIL or this box method. Then solving something with a squared means you need a quadratic, or remembering how to factor. And then plugging it back in there. All right. So this is your assignment, which is going to do a lot of these types of equations. So you're going to be following each of these steps to either graph, eliminate, or use substitution in order to solve.